We now derive the equations of kinematics for constant acceleration. We begin by making a few simplifications to the notation. First, we assume that the object undergoing motion with constant acceleration is initially located at the origin. This means x0 equals 0 meters and t0 equals 0 seconds. Therefore, the displacement, which was given by delta x equals x minus x0, can now be written as delta x equals x. Next, we drop the bold font and vector symbols. Since we are working in one dimension, the vector or directional nature of the quantities will be indicated through positive and negative signs. We start the derivations by assuming the acceleration is constant. In that case, the average and instantaneous accelerations are equal, or a bar equals a equals v minus v0 divided by t, or v equals v0 plus at, which we label as equation 1 and is our first kinematic equation. Note that there are 4 kinematic variables in this equation: v, v0, a, and t. If you know any 3, you can solve for the 4th. In order to obtain the second kinematic equation, we start with the expression for the average velocity, v bar equals x minus x0 divided by t minus t0. With x0 and t0 set to 0, as we have already assumed, v bar equals x divided by t, or x equals v bar t. In the case of constant acceleration, the average velocity can be written as 1/2 v0 plus v. We now substitute this into the previous equation to get a kinematic equation that involves the displacement. X equals 1/2 v0 plus v times t. This is our second kinematic equation. To get the third equation, we start with equation 2 and substitute equation 1 for v. This results in the displacement x equals v0t plus 1/2 at squared. Why do we have 2 expressions, equations 2 and 3, for the displacement? The answer is that the 2 equations involve different kinematic variables. For instance, note that equation 3 contains the acceleration, whereas equation 2 does not. To get the fourth and final equation, we solve equation 1 for the time and substitute it into equation 3. After some algebra, we obtain v squared equals v0 squared plus 2ax, which is equation 4. The table summarizes what we have done. We have derived 4 kinematic equations for constant acceleration. The 5 kinematic variables are x, a, v, v0, and t. Each equation contains 4 of them, as indicated by the check marks, and missing 1, indicated by a dash. Some problems require more than 1 equation to solve. Finally, these equations are valid only for constant acceleration, but that's okay. There are many situations, including projectile motion, in which the acceleration is assumed to be constant.